our graphic, and we'll see as far as we can go through and get today. We should hopefully end in a good spot. Where did we leave off here? And we should be, I think we said it's page 12, is that right? So, this is what you're going to be looking at next time. We'll start off with the very first one at the beginning of page 12. It prompts you to go through and graph that function for x's that are less than 3. So my general advice is I would go over to the side. Now, depends on where you want to go through and put this. I'll put it to the left on mine. You can put it on the right on yours. It doesn't matter. I give myself a table of values, an x and a y, a set of inputs and outputs. And as I'm listing this out, make sure you take note. You're going to start off, I guess the beginning point is going to be at 3. Oh, sorry. Excuse me, do you have a question? Okay. Do you need one? If you need one, anybody need one. You want to go check in your locker? Feel free also. If you want this one, get started. Now, when we're going through, the first value I'm going to start at on this chart is a 3. And after I start with that, I've got to ask myself, look at the domain that we're graphing over. It says x has to be less than 3. So, thinking about what our table would look like, what should we have as the next input after I plugged in a 3? What would the next logical input choice be? A 2, and then a 1, and then a 0, and maybe a -1. Maybe then we'll start to see a pattern emerge. Now, when we're listing this out, first thing I'm going to do is plug in. We did a -3 over here. I'm going to plug a 3 into the function, and we can do that by hand. We don't need a calculator. You have 3 squared minus 2 times 3. That's going to be 9 minus 6, which is what as an output? 3. So we know the graph should contain a 0.33. I'm not graphing it just yet. Go through and finish the rest of that table. Plug in a 2, plug in a 1, a 0, etc. That's what we got for our table of values. Yes or no? Okay. So now I actually probably, just so I'm looking at my graph, let's try plugging in a -2. What would the output be when I plugged in a -2? Hands up, please, if you can tell me what the output would be with -2. Yeah, it should be a +8. And after that, I don't think we're going to be able to fit much in our 10 by 10 graph. Now, all of these points are super easy to go through and graph, except for one. What's the only point that there might be some confusion about how to represent something? The 0.33. Is 3 included in the domain, yes or no? So since it's not included, 2.99 would be, 2.999999 would be. 3 is not. How do we denote that on the graph? I put an open circle right next to that point. That reminds me, as the person plotting the points, that when I graph it, that's the only open point. And I do that before I go in and start plotting points. So 3 is going to get an open circle. That's why some of you, I'd advise you to use the margin on the right there. 3 is an open circle. I think it starts looking like this. Do we get a graph that starts looking like that? Is that correct? And now the graph does not extend indefinitely. It's going to make this around. Oh, other things. If your graph is sloppy, yes, you actually lose points for that. Make sure, please, that as you're giving them out, if you can plot a point on the graph, you plot that point on the graph. Don't eyeball it. Don't kind of. Give a full, beautiful, comprehensive, and complete graph. Do we have questions on that? Why is there nothing to the right of the 3? Hands up and tell me why there's no more points after that 3. Yeah. Perfect. The x needs to be less than 3. Now we can go through and even answer a couple of questions, I hope, on here. Is this graph over what interval, from where to where, is this graph increasing? That's something that we look at as we go from the left to the right. From where to where is this graph rising? So I'd say the graph is increasing from, and we're going to use parentheses. We always use parentheses when you're giving increasing and decreasing intervals. Where is the graph decreasing? From where to where? Where is this graph constant? Is this graph continuous? Well, you haven't done that just yet. What do you think continuous means? Hands up, please, if you can tell me. What do you think a continuous graph would be? Yeah, well, I don't want to necessarily, well, mostly yes. Graphs going to go on infinitely, sure. There's another part of it, though. We don't want to necessarily, because you can have a continuous graph over a certain interval. So, kind of.
Would it need to go from 0 to positive?
So we wouldn't say that because we have a domain restriction on it. Is this, I'll change it up then. Is this continuous over its domain? Are there any breaks, gaps, times you have to take your pencil off the paper when you're making this graph? No. So is this continuous? I would say yes, because it's continuous over its domain. The domain was from -3 and down. Is it continuous from -3 and down? So anytime you have to take your pencil off the paper to graph that? No. There's no jumps or anything like that in the graph. Was that tough to do? No. Maybe. Now we've got, this is more of a true piecewise function. Up above, that was just more restricted domain. This is going to be a piecewise function. There's 2 pieces on it. I'll even go through. I use highlighters to show the difference between them in the beginning. It's okay if you don't have one. I start off, though, understand that when I'm talking about it, I'm going to reference the yellow function and the blue function. Looking at this, we're going to be giving out 2 table of values now. So I'm going to go over to the side here, and we'll do this color here. We've got an X and a Y. That's one of them, and then I'll have this one here for the blue function. So there's a split between these 2. Where does the split happen? I like to call it the transition value. Where does this graph transition from yellow to blue or blue to yellow, depending on how you're interpreting it? What x value does that switch go through and happen? At -1. So that means I'm going to have to represent -1 in both graphs. I'll start off with, and this one over here we'll say is the yellow one, and then the second one will be the blue one. We would list this out, the yellow one. I go through and say it's going to start at -1. What's another x value? What's another x value that we would list if you're trying to graph out the yellow function? Take a look at what's there. What would be the next value you would want to include in your table if that gray there writing is for that yellow graph? Luke? We've got a -1 there now. What's the next number? Take a look at what's there. Does -2 work in there? Yes or no? For the yellow graph? Does it? Yeah. So we're going to go -1, -2. What's the next value after that we go through and use? -3 and so on. So let's list out, and by the way, you shouldn't have to hopefully list out a ton of points on this. What type of graph is the yellow graph going to look like? It's a linear function. Yeah, same thing with the blue one. So the slope should be constant. Now, the next one is the blue graph. When do we start using the blue graph, or what's our transition value? So it's got to be -1 and up. Like we just said, x has to be greater than -1, so we get -1. 0 works, 1 works, 2 works. You could throw a 3 in there. It's really spicy. Now, we've got some questions to ask. Well, do me this favor. You all right now, fill in the yellow, fill in the blue. Not speculative. You can go through and determine what those will be. We're going to go through, we addressed it before. Proceed, and we'll deal with it as soon as we get to the graph, because the picture is what's going to give you your answer. Just work on completing the table of values first. Our transition value, where we flip-flop between the yellow and the blue function, is at -1. Well, our task is build a table of values that would represent the yellow, then build one to represent the blue, and then once we have that table, we'll worry about what happens with our transition value and gaps. What about for our blue graph? Hannah T, do you have any values? Well, do you want to do the yellow or the blue? You do. Okay, what do you got for -1? Okay? Just double check. This is for the yellow one. We got, you're right, this was 0, and then? Good, and then? And then? And by the way, that should work out because what's the slope between these points going to be? We're going to go up by 1 each time. As you're working, what's the slope of the yellow graph? 1. So these things are telling you the exact same story. What about for that blue graph? What would that table go through and look like? Irina, if you go through and give that out.
4.
And you're talking about a -1, the output would be 4. Yep. Good. 1 is 2, 2 is 1, and 3 is. And hopefully that makes sense because according to this, as the x's increase, what happens to the y values? Decrease by 1 each time. And what's the slope of the blue graph? -1. So you can hopefully see all these things are telling you the exact same story. I'm going to start plotting this out. And I've got a whole mess of points, but before I do that, I've got to decide where's the open dot and or the closed one. It's possible you get 2 open. You could have 2 closed. It just probably would eliminate it from being a function. Looking at what's there, which graph gets the -1 as a closed ordered pair? Carson, which one do you think? Perfect. So I'm going to put a closed dot here. And then that also means, by the way, -1, 4 does exist on the blue graph. Except, how do we have to represent it, right? Yeah, it's an open circle. And we know that because it goes right up to -1, but doesn't include it. So, I'm going to start listing this up. -1. We've got points at, and go through and start graphing this out. We've got -1, 0, graph 1, up 0, put a closed dot there. A little awkward, the colors might not stand out dramatically enough. This has a slope on it of -1. If you can give enough points to take you to the edge, do it. Don't kind of give a graph, give a legitimately good one. Bring that out, you can do something flat on it. That's one piece of this. Now the other graph starts off at the point -1, 4 with an open circle, and the slope on that was -1 each time. So don't worry about the ordered pairs, follow the pattern. You can do rise over right. There's a slope now of -1. Use some sort of flat, straight edge line. It's pretty accurate. By the way, what else should we make happen? Label your axes if they're not already labeled. Make sure that the graph extends. Arrows need to be at the end. People lose credit if the graph doesn't go to the end and you don't put arrows on it if it is in fact continuing beyond that. Why didn't we put arrows on our parabola up above? We did on one end. Why not both? It doesn't extend forever. It has a restricted domain. Now, if I'm going through and looking at this, from where to where is this function increasing? Hands up, please, if you can tell me. From where to where would this function be increasing? Carson? Perfect. It's increasing from -infinity to -1, Where is this function decreasing? Molly, what would you say? -1 to positive infinity. When is this function constant? Bruce? Never. Is this function continuous? Is the graph continuous? No. We had to say, is this discontinuous? Yes. So, you know, that's an actual calculus constant. Is that too tough for you to understand? You take your pencil off the graph, not continuous, right? Look out Yale. Now, was this tough for us to handle? No, not really. We're going to try one more here. How is this piecewise function different than the ones that we've worked on so far? Hands up, please, if you can tell me how this one looks different than the ones that we've done so far. It's not supposed to be some profound, well, maybe for some of us it is a profound realization, but this is not splitting the atom. Yeah, we've got absolute value in here, and we have not gone through and worked with absolute value before. Yeah.
We also have domains to work with.
You've got 3 different pieces for consideration. You have this yellow piece to start here, and this blue piece to start here. Let's see if I can get one more. Green. Okay. Now, we got that done. So, there's one other thing, though, that's more, it's a little bit different than before. I don't want to make it sound like it's more complicated. Yeah, the blue graph is stuck in between those two, so this means I'm going to have 3 pieces. There's a constant function in it that we haven't had so far. We're going to be graphing y equals 5. We have it squared in there. I think we might have had one up above. How many transition values do we have? 2 of them. What are the 2? Where do these switches happen? 0 and at 2. So I'm going to start off, and I'll use black for this one here. If I'm going to graph this out, I'd start off, this tells me to use the yellow function when the x is less than 0. So I'm going to go over here. I've got an x and a y. So, we have an x and a y. That's our first piece. The second piece is the one that's in blue. So I'll give that one out in blue. You've got an x and a y for that. And then our last one is in green, and I'll give an x and a y for that. So, what values will I be plugging into the yellow function? Tell me what that table is going to look like just on the left. Deborah, what values would you want to start with if you're using the yellow one?
0.
And what else? Close. X has to be less than 0.
0.
Yeah, we can, and you can keep going. I think that 3 points, at least in this case, 4, should be enough to represent that. Because, by the way, it's an absolute value function, so the slope on both sides is going to be constant. So if you've got 2 points, you've got them all. What about for the blue graph? What is that going to go to and look like when we're constructing that table? Mackenzie, what does it go to instead? That's right. Okay. We'll come back into the other one. Aaron, what would you say for the blue one? What's that table going to look like?
0 and 2.
Yeah, and we're only doing 0, 1, and 2. Now for the green one, what values would we go through and use there? Careful. Remember the alligator eats the bigger mouth? You said 2, 1, and 0. 2, 3, 4, yeah, that's going to get us there. And by the way, now we're going to find out, some of you guys are very sharp knives. I'm going to ask you to go in right now and fill out one of these tables. Who can tell me what table they want to go through and fill out? If you were to volunteer for one, you really want to hit a home run. I mean, this would be like playing T-ball. What? Yeah, what's the output each time?
5.
Oh.
No, that's-
Look at you. Now, we're not going to say that out loud. We're just going to pretend it's excellent work. Great job. Great job. Next one up, we've got an absolute value and a squared function, so fill in those two. Plug the absolute value in by hand. You're going to do that manipulation out and see what it becomes. Plug the numbers in. Do the original. Step by step. You'll be able to. I want to say that there's 7 substitutions that we have to go through and do. Some of them will be harder than others. Grace, which one do you want to do? Do you want to do the yellow one or the blue one? Sure. What ordered pair do you want to start with? Good. 0, 1 is a point. What else is going to be a point? Good. And 2, what? Great. Now we've got the yellow one to go through and do. And Jordan, would you go through and do for the yellow one? Yeah, any ordered pair you want to go through and get. 0, 3 is going to be on there. What else? -1, 2. What else? -2, 1. Keep going. And then now watch what happens. What's -4 going to work out to be? -4 is -1. And the reason I'm continuing with this table, do you know why I keep going with this? We got some sort of switch. Remember, absolute value graph kind of looks like a V because it takes that left half of the line and makes it positive. We haven't sort of found the V part of this graph yet. So let's continue on just one more point. You'll probably get rewarded for going through and doing that. We've gotten to here. Now I'm going to go to -5. So if I'm at -5, now we're back at 0. Notice that all my outputs were decreasing by 1, and then it started increasing by 1. That indicates to me that some sort of transition or turn has happened in the graph. So now we've got one last thing to figure out, what's getting open and closed circles. So what about the yellow graph at 0? Is that an open or a closed? What would you say? For the yellow graph at the point 0, 3, would that point be open or closed? It's open because the 0 is not included there. What about for the blue graph, Danielle? What do we know is happening at the 0? Is that getting an open or a closed? And what about at the 2? Also a closed. That probably means that over here, if this is going to be a function, what has to be the type of point we get at 2, 5? It's going to have to be an open circle, otherwise it would fail the vertical line test and not be a function. So I'm going to handle the easy stuff first. I'm going to plot, now 2, 5 was an open circle, and everything after that isn't. So, how good we are. We were at what, 2, 5? 2, 5, open here, and then 1, 2, 3, 4. And it was extending every value greater than 2. Is that right? Okay. Now, the other pieces that we have, let's try to graph out that plot in the middle, which was the blue one. We've got 0, 1, 1, 2, and 2, 5. So I'm going to graph out, go over 0, up 1. What was the point? Oh, okay. 0, 1, 1, 2, and 2, 5. Now, notice that the blue graph fills the open hole in the green graph, making it continuous to that. The next thing that we would have to go through and do is figure out, and that gets us to 0. We still need to graph the absolute value, and that one's going to get an open circle, and it goes to what, 0, 3, is that right? And that one, 0, 3, here. We're going to keep going down. I want to say it goes like this, is that right? Plotted all these points out. Oh, so far this is actually wrong. What did I need to put on the point at 0? Is there an open circle here? Okay. Then that. Put an arrow at the end. There's our graph, and it's sort of color-coded by piece. Do we have questions on that? Yep. You don't need to label the individual parts. What I will tell you is I like different colors so I can see them, but you don't necessarily need to.
If you're a visual person, you may find people almost
Now, over to the side here, from where to where is this function increasing? Anna, where do you think? I'd say -4 to 0, and then see how it sort of skips down. I'm going to put a comma there, and from 0 to 2, it's also increasing, but it's increasing in different intervals. And the reason I represent them separately is because that black region goes up, and then the blue one starts lower and goes up as well. They're not connected to each other. Where is this decreasing? Luke, from where to where would this be decreasing? -infinity to -4. Perfect. When is this function constant? Perfect. Is this function continuous? So I say that there is a discontinuity when x equals what value? Why is it not discontinuous at 2? Kind of. We had that actually at 1, and we did an output at both places. What's different about the output at 0 as opposed to the output at 2? They're going to have the same or common output. So the green would leave that hole open, and then the blue graph comes along and closes it. Was that difficult for us? Okay. Now, do me a favor. You can take your calculators out in just a second. We're going to show you if we did this right or not. So, everybody, please go to home screen and get yourself a brand new graphing document. So grab a new doc. Don't save anything that's there. We need to make a graphing one. Now, when you're in F1, well, let's start. How many of us are to this point? Raise your hand, please. Once you've got a brand new doc, fabulous. We get to this point here. You need to enter a piecewise function. Now, look at our last example. How many pieces did our last example have in it? 3? Okay, because you need to be able to answer that question in a minute. Press the button just to the right of the 9 that looks like it's got like the absolute value on it. Which of these looks like it's a piecewise function? When I start sliding over, so here's a problem. The one right here, you can go into right away if you want a 2-piece piecewise function. How many pieces does the last example we just did have? 3. Select the one next to it. You can pick how many pieces it'll have. So hit OK on this, and it'll say how many pieces. Well, how many did our last example have? 3. All right. Click OK. Now, up here, first one up. Was this one the one with the absolute value on it? So where do I get absolute value bars? Click on the button next to the 9. Go down there. Perfect. Select it. Go absolute value. And now you're going to make it look exactly like the text on the page. It was x plus 4, and I think we got to get outside of that. Perfect, but not great. And then x. Now, where do we get our inequality signs? Control equals gets into the inequality signs. So x is less than 0. This one I think was x squared plus 1. and that's 0 has got to be less than or equal to x less than or equal to 2. And then our last one was just a 5, and that was for x is greater than and not equal to 2. Now, how many of us have got all of that input? We'll wait a minute. Don't do anything. Make sure we're all on the same page. Make sure yours matches what's up there. This to me, and that should be a match. What's up in front of us should exactly coincide with that last example that we just did. How many of us have gotten this input now? Terrific. Hit enter, please. Did we do it right or not? Was that difficult for you? If the first inclination, if you have a question like this, is to run to the calculator, you don't understand the problem. Could I have gone through and showed you in the very beginning, you just hit the button on the calculator and it does it all for you? Yes. Does that mean you learned anything? No. And understand, there's going to be questions that you have where you don't get these calculators. The little yellow guys over on the side over there, I think they're the same one, not the exact same, similar to the one that you guys had over at middle school. These non-graphing calculators, you can get ones like this, or some of you, if you're really lucky, you'll get one of these nice solar powers. The bonuses, since it's so dark in here, it doesn't work. You get one of these guys here, and it does everything that this does, except it doesn't graph. And then you actually have to know what you're doing. Right? This is the calculus you guys are going to also have next year. And then for calculus, AP calculus, we go beyond and use these calculators again because it's calculus applied calculus. You know, if you use the math that an engineer would do not. So understand that there's some days you're going to be doing graphs without a graphing calc. You'll always have a graphing calc. So for your exams, well, sorry, not all of them, because I think this exam has one question, a piecewise at the end that I make you do just by hand. That's not part of the test. Part of the test booklet. Look on your Regents exam, and you'll always be able to graph this way. Now, we got one more thing to go through and work on. How many of you remember doing systems from freshman math? Like it might be fry math, elimination we talked about. Okay, fabulous. Take a look at what's there. Our task is, now there's 100 ways that you can do these. You can do these by elimination. You can do these by graphing. You can do it by substitution. For always, for our purposes, the only way that I approach these is by doing elimination. Your task is, as of right now, you have two equations with two variables. You want to find and get these two equations with two variables to go down to one equation with one variable that you can solve. If there's an equation with two variables, you can't go through it and solve it out. What we're going to do to make that happen is you have to force opposite coefficients to happen. So look at your x in this case and look at your y. Do I have opposite numbers in front of either the x's or the y's automatically? No. I don't have a -4 and a +4, or a 3 and a -3, or a 12 and a -12, or a 5 and a -5. So we've got to make that happen. The only way that you can make it happen is by multiplying your equations. You can do one or both to cause opposite coefficients to happen. What's the easiest variable? Take a look at what's up in front of us. What's the easier variable to cause opposite coefficients to happen with? You can do it on both. One path will be significantly less work and or easier than others. Carson, what do you say? Yeah, I want to get rid of the x. So right now, one's got a 12 and one's got a -4. What opposite coefficient value then am I looking to establish on these x's so they would have opposite numbers in front? Numbers am I trying to get? 12. Bottom equation is perfect. What about the first equation? Is that perfect? No, it's actually kind of good though, because what do we have to multiply 2 by? Not even a negative one, just a +3. Now, when you do that, my advice is always the same. Stop looking at the work from above. I even put a little line here to divide it off. What's the new first equation going to be? Now, from here, you've got to go through the second equation, did not change. You've got 12x plus 5y is equal to 1. Your task was to get opposite coefficients to have that they don't naturally occur. In this case, do we have opposite coefficients? No. Yes. One other thing, and I don't care what they told you before, sometimes we need to go through and just sort of put some bleach on our brain. I have to do that. If you go through right now, you might have had people before tell you, oh, you can add the equations, you can subtract. You're not good at it. Stop thinking. And we're just going to own it. It's not our thing. Adding, you're amazing. You're exceptional. Let's just add these equations together. You have two equations, and we have opposite coefficients on the x. Let's add them together. This would give me a 14y is equal to 70. From here, I would divide both sides by 14 is this what? 15? No. 5? Sorry. Yes, because it would be 50 and then 20 more to get to 7. So we've got the y value. How can we figure out the x? No. Plug that in. We'll go in and do that out right now. I stick with the positive equation. Well, that's 5 times 5 equals 1. Well, that's 20. We get x equals, is it negative 2?
Yep.
So we get to here. Now is where it gets a little bit awkward. How do we give out our answer? Well, there's two different ways. I could say x equals negative 2 and y equals 5. That's one way of giving the answer. It's generally accepted that if it's x and y, you could also state the answer as an ordered pair, 2 comma 5. In terms of a Cartesian geometry point, a place where they meet is when x is negative 2. The value that they both would have there is 5. You have questions on that part? Who remembers those systems? Outstanding. This was how you did them as a freshman. Now, this is how you do them as a not freshman. How many equations do we now have? How many variables do we now have? Okay. I'm going to go, and I need to make this go from, I'm numbering my equations, that's it, so we're talking, when I say the first, second, and third, we know which ones we're talking about. I need to go through, right now I've got 3 variables. I need to make 3 variables down to 2, and then 2 down to 1. That's the process. The process isn't any different than what you had before. You've got 3 letters up there right now. Do any of them have opposite coefficients right away? Yeah, I actually look and I'm like, well, there's a way we can get opposite coefficients out of almost all of them. Which letter do you want to eliminate first? Or which one do you think is easiest to get rid of? I think the y's are going to be the easiest to get rid of. Now, as it stands, I've got 3 equations with 3 variables. I'm going to try to eliminate the y twice. Which 2 equations do I want to use to eliminate the y the very first time? Take a look at what's there. You probably want to pick the easiest one. What do I say? Yeah, I'm going to, and I write down in the margin, I'm using equations 1 and 2 right now. So I will write down right here, 1 and 2. Now, do 1 and 2 have opposite y's already, or do I need to make opposite y's? They've already got them, so just write out the original, 2x plus y plus 8z equals negative 1, and x minus y plus z equals negative 2. So these equations, when they merge or get added together, the y's eliminate. I'm left with 3x plus 9z equals negative 3. So does this equation have a y in it? No. I need to make that happen one more time. But which equations can I not use? 1 and 2. So that means I've got to use 1 and 3, or 2 and 3. I can't use 1 and 2. So, how would I want to eliminate the y's a second time? Would I want to use equations 1 and 3? Or would I want to use equations 2 and 3? I can't use 1 and 2 because I've already done it. All right, let's try using 1 and 3. Now, if I use 1 and 3, do they eliminate right away? The y's eliminate right away. You said it. Use the word. First, first equation, we got to multiply it by. How much did you say? So what's the new first equation going to be? And then we're going to use the third equation. Does that need to change, or can it stay the same? Stays the same. 3x minus 2y minus 2z is equal to 2. Yes. These equations now come together. I've got 7x plus 14z equals. How many equations do I now have that don't have a y in it? 2 of them. So guess what I now do? Make these into a 2 by 2 system. We've got 3x plus 9z equals negative 3. And we have 7x plus 14z equals 0. Why is this awkward? Yeah, you're going to have to change both of them. Do we want to get rid of the x or the y? I see the x is easy because I can easily see what opposite number I want in front. What number do I want in front of the x's, positive and negative? That's not the question you were just asked. What number do I want in front of the x's? One will be positive and one will be negative. You want a 21 in front of the x's. Not talking about a multiplier. We're saying what coefficient or number in front do you want. How am I going to make that happen? Well, the first equation I'm going to multiply by. Let's do a 3 then here. So our new system, both lines are going to change. And this new first line is negative 21x minus 63z equals positive 21. And this would be 21x. It equals 0. We've got what 14 times 3 is. That 42. Okay. Positive plus 42z. Now, we're going to add these together. What do I get if I take negative 63 plus 42? Negative 21z is equal to 21, divide both sides by negative 21. What does z come out to have as its value? How can I figure out, what value can I figure out next? The x, go up one line, plug in, evaluate out, show that work on your paper. You can tell me what the x is going to equal. Did you get it yet? And then when you get that done, you plug back in and try to find the y. Is x equal to 2? Yeah. Now plug that in to get the y value. Everybody get our y value? Is that what we have? Yes or no? Yeah? Okay. So how many variables did you now solve for? Was this a lot of work? Sure. Just so we're clear, we started off with 3 variables. Pick it so you can go down from a 3 by 3 to a 2 by 2. Pick one variable, eliminate it twice, then go from a 2 by 2 down to a 1 by 1. Yeah?
Solving for y, should we do the version where well,
Before the multiplication, if that's what you're asking.
yeah, we would use one of the top versions.
Either of these would work. And I wouldn't use the bottom two because they just have bigger multipliers in front of them. Either.
How would they work if they didn't go?
Oh, for Y?
Yeah.
Oh, I'm sorry, for Y, go back up to the very original. Okay? Guys, your work for tonight, make sure, please, you bring your Chromebook with you tomorrow. And things that you need to make sure will get done. What's due on Sunday? Seems like you're getting in a routine. Good job.